Good morning, good afternoon, good evening, everybody, depending on which time zone you are. Um, I'm Nick Scarmeas. I have the privilege of hosting and coordinating today's HIAAD session. So without further delay, so that we can have more time at the end of the talk for discussion, I would like to introduce Angeliki Tsapanou. So briefly about Angeliki, she did her PhD with me. And she's a neuropsychologist with a particular interest in sleep and its relation with cognition or with diseases of cognition, and in relation to neuroimaging, but also in relation to other markers. And right now, Angeliki is an associate research scientist. She's a faculty at Columbia University. She also has an affiliation with the Athens Alzheimer Association. And recently, since recently, she has an appointment with the University of Patras. Um, so she's currently running a HIAAD, exploring the association of sleep with cognition. But I think it's better if she tells us some of her work that she has done and where she's heading to. So Angeliki, the floor is yours.
Thank you, Dr. Scarmeas, and thank you everybody for joining us today. I'm glad I can present you our work on sleep. Let me share with you my slides. Okay, can you all see the first slide?
No.
Right, thank you. So today I will focus on our work on sleep and sleep phenotypes and genotypes. Initially, I will give you our research regarding sleep phenotypes, association with cognition, cognitive changes over time, and dementia. And then we will move on the second part regarding sleep genotypes and my current work on polygenic scores for sleep. And finally, I will present you my future steps on my work. In generally, is sleep associated with cognition? And if yes, in which way? Sleep as an early symptom of cognitive decline, or maybe sleep being the reason for decline or a neurodegeneration? And what can we gain for brain health in general through these associations of sleep and cognition? Existing literature shows the association between sleep and cognition. In general, we do have quite a few cases indicating a strong association of different sleep phenotypes with cognition. Sleep duration in middle and old age is associated with incident dementia. And sleep quality overall also, and the impact of sleep duration is strong on specific cognitive functions. And also from our work on Alzheimer's Association in Athens, we also have seen that people have increased problems with sleep during stages of mild cognitive impairment or dementia, something that affects both of them and their caregivers. One of my first studies at Columbia University was this one with using the data from the WICAP, the Washington Heights Inwood Columbia Aging Project. For the ones of you who are not familiar with, this is Manhattan in New York, and this part here, the upper side is called the Washington Heights Inwood areas. So this study has been going on since 1989 and it's still active. And what we tried to do with this data with people coming in follow-ups every 3 years was to examine if there is an association between sleep and cognition. So In this first paper, we found that in a community-based study of older people aged 65 or older, daytime sleepiness, meaning feeling sleepy or drowsy during the day. So although someone has slept at night, he feels sleepy or drowsy during the day. So this daytime sleepiness was an early sign of cognitive decline in this group of community-based older adults. Also, the same problem, daytime sleepiness, was associated with poor cognitive function at the baseline. So we took this data and we wanted to examine longitudinally what are the association with incident of dementia. And what we found was that the same factor again increased daytime sleepiness and sleep inadequacy were significant risk factors for dementia. And here we can see these results graphically. In this first graph, we see people having trouble staying awake during the day, differing because this is based on a self-reported sleep questionnaire, all of the time having trouble staying awake during the day, is the group that has a higher risk of developing dementia in the 5-year follow-up. Also regarding sleep deprivation, so getting the amount of sleep needed, we also see that people who do not get the amount of sleep they need at night, these are the ones who are in higher risk of developing dementia and specifically Alzheimer's disease type. So right after, we thought of examining similar association on a different data set. So these 3 studies were based on the data from people from Upper New York, and we thought, okay, what is going on a different landscape? We used the Hellenic Longitudinal Investigation of Aging and Diet, the HIAAD study, which it has been reported in some of the previous talks of HIAAD. Briefly, this is a population-based epidemiological study designed to estimate the prevalence and incidence of MCI, Alzheimer's, other types of dementia in the Greek population. And the interesting part is that it has quite similar design as the YCAP study, the one that I mentioned you before from Colombia. So that was quite easy to examine similarities or differences with the previous studies. So what we found in Greek older adults, it was that sleep quality and duration were associated with memory. More specifically, in the graph here on the left, we see that if we make 3 sleep duration groups, the short sleepers, regular sleepers, and longer sleepers, meaning sleeping more than 8 hours per night. Regular is 7 to 8, and short is less than 7. We see that the longer sleepers are the ones with poorer memory performance in the neuropsychological assessment. This is something interesting, and this is something that, although so far we know the U-shape of the association between sleep duration and cognition, lately we keep seeing that regarding older adults, the longer sleeping is more associated either with cognitive decline or with dementia. We will get back to this later. And also sleep quality, poor sleep quality was also associated with poor performance in the neuropsychological test examining memory in this group of Greek older adults. So, okay, we see that we have an association between sleep and cognition at the baseline. Then we see sleep with longitudinal analysis, cognitive changes, and sleep with incident dementia. We took a step back and we actually wanted to examine what's going on with the people with subjective cognitive decline. They come at the clinics and we perform the neuropsychological assessment. We do not see anything pathological out of norms. However, they do complain about specific cognitive declines. So we do know that there is this association between cognition and sleep. We also know that there is an association between cognition and subjective cognitive decline. What is going on here? Sleep and subjective cognitive decline. The interesting part of this study was that we ran the analysis in both data sets, both HIAAD and HIAAD. And we had the results for the data for subjective cognitive decline. We included only older adults age 65 years or older, including also neuropsychological assessment. And what we found was that at any given level of objective cognition, meaning that even after adjusting for objective cognitive performance, sleep disturbance we saw that was accompanied by subjective cognitive decline. And it was very interesting that we had the replicability in two ethnically, genetically, and culturally different cohorts, adding such a validity to our results. And here we can see these results in this table. On the left, we see the results for the HIAAD cohort. On the right, we see for the HIAAD. And as you can see, it is very interesting that we have quite similar results. Sleep problems are being associated with subjective cognitive decline overall as a total score that we had created, but also regarding complaints about specific cognitive domains, memory, naming, calculations, and orientation for the HIAAD. And here we can see the results graphically. Although they look identical, these two graphs represent the two different data sets. On the left, we see the results for HIAAD. On the right, we see the results for HIAAD, with more sleep problems, indicating also more complaints for subjective cognitive decline. Thus, we can see that so far we have sleep function being associated with subjective cognitive complaints or decline, then with cognitive performance, as this is measured by the neuropsychological assessment, and longitudinally with cognitive changes and with incident dementia. And here someone would ask, okay, so which one comes first? What's the causality of these results? I believe that so far we could answer that it could go both ways. Sleep, either sleep as an early symptom of an upcoming neurodegeneration, or sleep causing the disease or cognitive decline. In order to go to get closer to the answer of these questions, we could only use genetics and brain biomarkers. So we thought of using the genetics of sleep and specific also biomarkers, including the data for sleep, genetics, and brain, in order to get closer to the answer regarding what's the association between sleep and causality and aging. One of the first studies, including brain morphometry at Columbia University, showed an association between sleep problems and brain morphometry. Again, the same problem, increased daytime sleepiness, was also associated with less total gray matter volume and total cortical volume. Further, longer sleep duration again was associated with less left entorhinal volume. Again, these results are based on a group of older adults. And here we can see these results graphically. As you can see here on the left brain, these are single subject examples. So here was a participant, both were male, similar age, similar years of education. With increased daytime, excuse me, here on the left, as we can see, is someone with normal sleep, and also we can see a dense brain, so a good cortical volume. In contrast, here on the right, we see someone with increased daytime sleepiness, and as it is obvious, less total cortical volume. Two other single subject examples are here regarding sleep duration. We see here on the left a regular sleeper, meaning sleeping every night 7 to 8 hours approximately, and having a very healthy left entorhinal thickness, in contrast to the person here on the right with a long sleep duration. And by long sleep duration, we're seeing people reporting sleeping 10 or 11 hours per night. And a much smaller left entorhinal thickness. One study now, again, including brain morphometry, was this one with the hippocampal subfields. So, including data of a different Greek data set, the Albion study, we were able to run analysis on hippocampal subfields and use objective now sleep function. And we found a greater frequency of awakenings during sleep being associated with an increased volume in the right presubiculum body. So we also see association between objective sleep function and specifically hippocampal subfields. So moving on the genetics part, we know so far that there are some genes being associated with sleep. For example, clock is a very famous one, being associated with insomnia or circadian rhythms. Period with sleep homeostasis, bmol1 with sleep deprivation, cry with sleep homeostasis again. It has also been seen that these sleep genes have been also associated with cognition, mild cognitive impairment, or Alzheimer's disease. So a question that came up to us was, okay, so there is an association, as we can see, between sleep and cognition in a genetic level. And one of the first studies that we did, including genetics, was this one examining the association between apolipoprotein E, the allele 4, and self-reported sleep disturbances, again in non-demented older adults, showing a significant association between self-reported snoring and self-reported sleep apnea with the APOE4. And after performing a small analysis based on the ethnicity, we see that these results were mostly driven by the Caribbean Hispanics. So I showed you the genes that are associated with sleep. Something that we start working on in general is, instead of using single genes and single SNPs, including all the possible SNPs and genes that we can for a specific phenotype. And that's how my idea for my K99 ROO grant came, was to use a polygenic score. So instead of using single genes, creating a polygenic score associated with sleep and examining its association with cognition cross-sectionally, then including brain measures and also examine its association longitudinally with cognitive changes and incident dementia. And as a part of the last step of this grant, it's proposed to generate a polygenic score based on candidate genes for cognition now, and examine any overlap between these polygenic scores, the one for sleep and the one for cognition. So for the ones who are not very familiar with a polygenic risk score, PRS, or a polygenic index, in general, these PRS studies started with, based mostly with people with schizophrenia, or with cardiac arrest. That's why it was named polygenic risk score. However, now it is also used only as maybe a positive association. That's why we prefer the term polygenic indices. But no matter how we call it, it refers to the same thing, which is a sum of trait-associated alleles across many genetic loci, typically weighted by effect sizes estimated from a GWAS analysis. So what we actually do with a polygenic score, we can detect or predict a shared genetic etiology among traits. In order, the good thing using a polygenic score is that you don't really have to have a really large data set as the ones you need to run a GWAS analysis. So what you need, though, to have is to have an already existing GWAS analysis prepared. And for our case, we use this data from Dusty et al. From 2019, where him and his team found and created a polygenic risk score, identified associations between sleep duration and diseases, and specifically for habitual sleep duration. So what they actually did was, through a GWAS analysis, creating and finding 69 genes, so creating this polygenic score for sleep duration specifically, indicating that the higher score was associated with longer sleep duration. And this is a study based on the UK Biobank, including more than 404,000 participants. Another study, again in 2019, by Cox and colleagues, reported that they actually created a polygenic index of chronotype and sleep duration related to self-reported sleep duration and cognition. So what Cox did was our idea, including cognition. However, the biggest limitation of this study was that they did this study only in the age group of 70 to 76 years old, so very, very specific, only on the 8th decade of life. So, computing these two studies, we created the aim of our study, creating a polygenic score for sleep duration and examining its association with cognition in our data set of adults using the data from Columbia University and including the whole age range, so 20 to 80 years old. This is an example of the information needed in order to create the polygenic score. So this was a cross-sectional design, and we included people aged 20 to 80 years old. We also had for everybody a neuropsychological assessment, indicating the domains of memory, fluid reasoning, speed of processing, and language. and covariates age, sex, and education. So we had a sample of 173 participants with data for sleep, cognition, demographics, and genetics. The question that we wanted to first validate the sleep genetics, the polygenic score, was derived from the Pittsburgh Sleep Questionnaire, and we used the sleep duration questionnaire. During the past month, how many hours of actual sleep did you get at night? And this might be different than the number of hours spent in bed. So we had 56 years of education, quite highly educated, with more than 16 years mean years of education, and almost equally distributed by sex. So we managed to have a good prediction of sleep duration. Indeed, in our data set, we managed to create this polygenic index for sleep duration using the data from DUSTY, and this sleep duration polygenic score was also associated with self-reported sleep duration. So indeed, the people who had the genetic predisposition for sleeping longer at night, they had also reported that they indeed sleep longer at night. And on the next step, we examined this the association between this sleep polygenic score and cognition. So as you can see here, it was significantly associated with the global cognitive score, and specifically with the domains of language, speed of processing, and fluid reasoning. In what way? So longer, higher, more sleep duration polygenic index was associated with a better performance globally and in these domains. And as we can see, and here is a graph indicating this, and as we can see why this could happen, this is mostly, as we can see, because the results are driven from the younger group, so 20 to 40 years old. So far, we have that higher values of sleep PGI predict longer sleep duration, and in a sample of cognitively healthy adults, sleep PGI appeared significantly associated with different domains of cognition as well as global cognitive performance. And this sleep duration PGI was associated with the domain specifically of fluid reasoning, speed of processing, language, and global cognition. So considering that sleep deprivation is a consequential factor of cognitive decline, maintaining probably a longer sleep duration in cognitively normal aging matches good with cognitive performance. And this stronger association was indicated in the younger group, so that younger participants with longer sleep polygenic index performed better in global cognitions and in the specific cognitive domains. So after this, we wanted to take a step further and expand our knowledge that we gained by the sleep PGI on cognitive PGI. So we actually created this polygenic index for cognition, meaning actually for intelligence, for an IQ test. And we found that also across age, so 20 to 80 years old, a higher polygenic index for cognition was also associated with better performance in the neuropsychological assessment, again, results mostly driven by younger adults. And our current analysis includes First, the longitudinal analysis between sleep polygenic index and cognitive changes over time, showing again that genetic predisposition for longer sleep duration can work as a protective factor against declining speed of processing, again, only in the a younger group of adults. We do not see this for older adults. And then my major next step is to include more brain markers on this association, examine the cognitive polygenic index with any incidence of dementia, and also to examine any overlap finally between these two polygenic indices, the one for sleep duration and the other for cognition. So thank you.
Thank you, Angeliki, very much. Can you hear me well?
Yes.
Yeah, great. So I think you took us in a long journey from neuropsychology and clinical measures to neuroimaging and further down to genetic associations. So maybe we can, I think we have time for quite a few questions if there are any. So I don't know if somebody has a question. I can also be checking through the chat, but also from people who are on the panel. Marina, I see a hand being raised, right?
Yes. Hello.
Hi.
Hi. Sorry, my connection is. Thank you, Dr. Tsapanou, for a very interesting talk. I have two questions. Maybe you have mentioned it in the beginning and I missed it. The first one is for regarding the setup of these studies is the quantity and the quality of sleep. Is that based on the participants' perception? I don't mean perception. I mean what the participants said, or were they also studies like sleep studies for these persons where they were monitored?
So regarding the first studies of Columbia University, the YCAP, the RUN, and the CR, these are all based on self-reported sleep questionnaires. So only based on what the actual participant is reporting.
Okay.
And the one mentioned, for example, the Albion, we used objective, as I mentioned, sleep parameters using a specific wearable indicating objective sleep function. And the final ones, of course, using the genetics of the participants.
So the second question is based on that objective value. So these participants, they were tested for the respiratory function during sleep. So how many apneas they were probably having during the night, because I'm guessing this is an important factor, and a lot of people. I'm not a neuroscientist. I'm not in that field, but I think a lot of people have accumulated damage from a lot of apneas where their oxygen is deprived for some. In some people a lot, and they have to wear a mask, but a lot of people don't know it. So are these people checked that they don't have any respiratory obstructions, or?
Correct. So this is based on a watch, but meaning like on a specific like watch, which is a wearable. So we get the information only from this one, and it is like an actigraphy. And the participants are being asked, and we can see on their clinical history and the medical history if they have sleep apneas or not. And for almost all of the studies that I mentioned, even the ones with self-reported questionnaires, we do not adjust also for reported or from the medical history sleep apneas. For most of the studies, for most of the data sets, luckily, there aren't many people with sleep apneas so far, but this is also something that can be examined further.
It's worth checking, because it's a lot of this drop of oxygen is an accumulative damage during years, and it could be a factor of dementia. Yes. Thank you very much.
So Costa, just give me 1 second just to clarify something in relation to Marina's question before you ask and you you make a comment. So this watchpad device is not a polysomnography test, but it's a correlate of this test. So in order to have a proper diagnosis of sleep disorders, you need to have other you need to have a proper sleep test. So there has been some validation of this particular watch. So it's a correlate, it's not perfect. But it's a very valid point. We have also analyzed and we have seen associations between different stages of sleep, like deep sleep and cognitive performance, and also levels of CSF biomarkers, levels of amyloidosis in the brain. And in the ADPD conference, Angeliki and Yannis Foukarakis who will have an oral presentation where we looked at the association between the apnea-hypopnea index. So it's a parameter that we get from this watchpad, and this is the main parameter that is being used to diagnose sleep apnea, the apnea-hypopnea index, and we see an association between this apnea-hypopnea index and cognitive performance and brain amyloid. So there seems to be a relation there. It's very interesting, and it relates also to your question and to what Angeliki has already explained to us.
Yes, thank you.
Costa, sorry for the interruption.
Oh, no problem at all. Let me compliment Dr. Tsapanou. Very nice work. I'm sure someone has educated you that your grant is called a kangaroo. At least that's my favorite expression. So sounds like you're about to make a big jump. Well done. I have conceptual question. So clearly polygenic risk indices or scores are presumably we're born with. But your outcomes, both the sleep side and the cognitive side, their relationship is hard to disentangle, because your real question is which comes first. I would wonder, A, what methods would you use? Could you do a path analysis? Could you do a longitudinal study where you have a larger sample and you look at the emergence of a sleep problem in relationship to cognitive decline? So I think giving a little bit of thought to that will be helpful, because I doubt that the mechanism linking sleep disturbance to a cognitive outcome is unitary. I think already you've heard a couple of considerations. The associated sleep apnea could be a problem, but there could be many other. The age-related loss of slow-wave sleep, for example, is the driving hypothesis for many of us right now. So the question is, how do you tackle that complexity, especially the issue of sequence? A, and B, how do you tackle different mechanisms? Because ultimately, I think just looking at symptoms isn't likely to be very fruitful.
Yes, very interesting question. And I wish I had a very straightforward answer, but I'm working on this. What we also keep seeing from also different studies, that I didn't include everything in here, both regarding sleep genetics and cognitive genetics, we also keep seeing that specifically, let's say for here, sleep genetics are mostly interesting in younger groups. And as we get older, we do not see significant associations there. So that might tell us that genetics of sleep play more important role as we're older, and then other factors are more important in our actual aging. So one part is to example, which is this other factor? Is it like brain maintenance that plays more significant role after the age of 45 or after the age of 65? So this is something that we keep seeing in the latest studies, and it's something that keeps also questioning me all the time. And I'm thinking, okay, so this is quite interesting. We are talking about genetics, but as we can see, we cannot conclude that the one comes first or the other comes first. We do not see that genetics are very important. We know that they are here before us, but we do not see them driving very clear these associations, especially regarding dementia. So, of course, a larger sample genetics analysis would be interesting, and also including tau, amyloid beta, and see how these affect this relationship with sleep genetics and cognition would also definitely give us more definite answers. And another step that I don't know, but I hope that would give me also some answers. As I mentioned, I do keep seeing specific sleep problems being associated with cognition, either cross-sectionally or longitudinally. For example, the increased daytime sleepiness. So my really next focus would be to create a polygenic score for daytime sleepiness, and see, is this more, does this explain more of the variance of cognition over the years? Because maybe we get some answer there. And B, how many, do we have any genetic overlap with the genes associated with sleep duration and cognition? So I don't know if I answered your question, but these are my thoughts based on this.
You're clearly thinking about it, and that's what I was trying to see. So I think your point, picking one mechanism, at least for what you're trying to do to get its own genetics going and understand how that mechanism might be affecting is a good one.
I think that's the most important point, what you raised, Costa. It's to disentangle a little bit, but I think, in these studies, we have the cognitive phenotype, we have the sleep phenotype, and then just below this, we have the neurodegeneration related pathology, because many of these studies have tau and amyloid PET, and in our studies, we have the CSF versions, and we have some correlate of the vascular versions through the MRI of the vascular biological pathway, and then we have the genetic part. So somehow, I think Angeliki, I think it's a great suggestion by Kostas. You can somehow, I think, play with the variants explained and the residual variants of either the pathology part or the clinical part, and see what relates to that, or with some more complex approaches like the path analysis. Clearly, some variants of the phenotype may be related to neurodegeneration, some other variants may be related to sleep genetics. And, there are many ways to play this game, but it's the most important question that is still, hanging, and we need to answer. Any other question?
Can I add one?
Of course, Yanni, of course.
After sharing my best wishes to Kostas for fast recovery, and really congratulate Angeliki for the great work that she has done in Colombia in collaboration with Nikos, Scarmeas, as well as the work she's doing in Alzheimer, Athens, and for the new position in University of Patras. It's really great. So one first question. I don't know if there is evidence or you have searched in your data or it's something known in literature. If we accept that, anxiety and depression coming together with some symptomatology related to sleep disturbances, have you any patients that they got any antidepressants and their sleep pattern was improved? And did you see any effect of that? Because
yes, very interesting question. Thank you.
Because what I'm saying with that, you could have, specific brain, biomarkers like exosomes that now we're doing with Nikos, that you could discriminate the effect coming from anxiety changes, molecular changes, and contribute to that. And the one that is irrelevant with anxiety or depression pathology, and it is based on the genetic of sleep genes.
Thank you for the question. So for almost all of the studies that I presented to you today, we have control for both anxiety and depression. And we have seen that the results do not change after adding anxiety and depression in the models. So this is the one. And then we have also created a sleep medication variable, and we have looked if this, so people who do take sleep medication, if this affects anything, and they do not. Also, the results that I presented, they are not affected by these variables either. Although we do know, that either sleep medication or anxiety and stress, they do play a role. However, we see that probably the sleep and its association with cognition is stronger than the effect these people have because of their mood, their anxiety, or their depression.
Thank you. Thanks a lot, Nikos and Angeliki. Great presentation once more, and very interesting points. I think it will raise a lot of basic and clinical questions, and hopefully some collaborations among HIAAD members.
Definitely, I'm definitely open for that. Thank you.
I don't see any questions in the chat. Does anybody else, unless I'm not seeing it and it's coming through another channel, but does anybody who is present want to ask anything? Yes, Marina.
Hi, sorry, hi. It's still on the same thing. You just mentioned the daytime sleepiness, and I'm going back to this apnea thing. I mean, the reason is that I recently did a sleep study of my own, and I had to fill out all these questionnaires. I think one was called the Berlin questionnaire, and another one was like a sleepiness scale. I don't remember, Epworth or something like that. And the main questions on all of them were how sleepy am I during the day, and under what circumstances? I mean, will I fall asleep watching a movie? Will I fall asleep sitting? Will I fall asleep? But a lot of questions about daytime sleepiness. That's why I don't know. I thought first they take the score and then they hook you up to all these machines and everything, and they see how many hypoxic events you have during the night and all that. So it might really be worth doing that for your participants, I think, because after reading about it afterwards, I realized how many people have that, and that you don't realize. If you sleep alone, for example, and nobody ever tells you, it could be years before you actually realize that you have that during the night. Yeah.
Or if you're not using a sleep diary, then you really don't realize it. It's like underdiagnosed.
Yeah.
So, and some people, after we bring up the question, they start thinking about that and realizing that they do have that feeling. So yes, definitely. Thank you for pointing that out.
Thank you for the talk.
Okay. Any other comments? Okay, so I don't see anything else. So maybe we break a record and we will finish maybe 5 minutes or so earlier. So I would like to thank everybody for attending. And I guess I'm not sure, Yanni, when is our next HIAAD, presentation, but I think we will find it in our calendar. So, but I would like to say again, Happy New Year to everybody. It's our first meeting for the year 2025, and we will see each other hopefully at the next presentation. Thank you.
Thank you. Bye.